everyone. This is a presentation of cybersecurity natural language processing project, and this is the core team in Fordham University. Our theme is Let Text Data Tell Story. Cybersecurity is an essential issue for overall cybersecurity of the country, and it is not only about technology, but also about laws and strategies. However, analyzing cybersecurity strategy documents is very difficult because it requires knowledge of multiple domains. But with the help of the text analytics methods, the documents can be understood more easily, automatically, and efficiently. This project conducts a machine learning-based text analytics of national cybersecurity strategies, and our research objects are the cybersecurity strategies files of 76 countries in the world. Our main problem is to build a model or a tool to analyze the text data of cybersecurity strategies of different countries to generalize their topics, classify each sentence, and assign it with a tag of a category. Our data has two sources. The first part is 80 PDF documents about cybersecurity strategy of different countries, and the second part is 193 PDF documents of cyber wellness profiles. And here's a source link.
Here I will introduce the methodology part of our project. As the amateurs of cybersecurity, this project uses the methodology on the right pane to detect the hidden values and insights behind the raw text data. That is, let the text data tell a story. First, we use the Python package, the PDF miner, to transfer both of the cyber wellness profiles and the text data from the PDF to text format. The tedious text data, such as the contents appendix and the title of the figures, were removed. Finally, nearly 5,000 sentences are cleaned and completed. These sentences are labeled by our initial dictionary, which is derived from the cyber wellness profile, term frequency, and the name of the categories. We got nearly 700 sentences labeled. These sentences are further tokenized, stamped, and their stop words were removed. We applied TF-IDF model to do the feature extraction part. Next, we come to the model building part. Here we create 10 classifier chains. Each classifier chain contains a logistic regression model for each of the 21 labels. The models in each chain are ordered randomly. We applied J-code score to evaluate our model. Finally, the model is applied to predict the sentences classification. Around 4,000 sentences are applied into this model, and 300 sentences are labeled. The remaining sentences are applied into LDA model, and the topic extracted are analyzed in the geographic dimension and the wealth dimension. This slide displays the sentence tokenization method just I have mentioned. We use semi-supervised machine learning model in our project because we suppose the external text data could not promote the classification process very well, and the semi-supervised machine learning algorithm can benefit the text mining procedure by multi-times learning and optimization. This slide displays the sample of our initial dictionary. The conditions column means that, for example, the institutional support is a subcategory of the children online protection, so only the sentences both contain the child or children keywords and the institutional support keywords can be classified as the institutional support. This word cloud displays the 65 independent variables extracted by our TF-IDF model. We apply J-card similarity score to evaluate our model. Score of ensemble model is around 40%. For a multi-label text data classification problem with more than 20 labels, it is an acceptable result. Here we show two kinds of sentences labeled by both our initial dictionary and our model. Both of the two kinds of sentences are classified accurately.
Here comes to the result analysis. We first conduct the overall label results analysis by plotting the category importance bubble charts. And there are more than 1,000 sentences are labeled from the semi-supervised model. In the right bubble chart, the size of the bubbles is the number of the sentences belonging to the category, which means the importance of the category. And we found that standards, regulation, and compliance, public sector partnership, intrastate cooperation, and responsible agency are the top 5 essential categories in the bubble charts. And we conduct a label result comparison between the developed country and developing country by plotting the bar charts in the right. And 0 represents the developing countries and 1 represents the developed country. And the value of the bar means the importance of the category. Comparing to the developed country, developing countries mainly focus on improving the completeness of standards of cybersecurity requirements. But the developed countries attach more importance to the supervision upon certification of agencies and the beneficial cooperation between states. And we drill down our analysis to the detailed part. We analyze the standard based on the countries. In the map on the right pane, the color depth means the number of the sentences belonging to the standards. The more deeper the color is, the more important standard in the country's cybersecurity strategy will be. And finally, we found that United States, China, Saudi Arabia, Denmark, and Sweden are applied with a darker color. They have advanced and mature cybersecurity strategies and may set up the standards in the surrounding area. And in the third analysis part, we compare the topic modeling results in the 2 dimensions as well. And we found that defense is the most important topic in the developing country, and which may indicate the developed countries are attacked in a high frequency. And the topic difference in different continents are vague, which can show that the cybersecurity issues happen almost evenly in each continent. We can draw some conclusions from this whole project. This project produces a sentence classifier machine for the raw text data to classification and tagging process without enough professional terminology dictionary. And standard is the most important category in the labeling process. And the topic modeling results vary a lot in countries' development level, but perform similarly in the continental dimension. For the future research, we can improve the three aspects. First, we can improve the sentence tokenization by improving the tokenizer through recognizing the complete sentence structure and entities extractions. Second, we can improve the word dictionary, and we can do this through more documents on cybersecurity. We may improve the performance of the word directory for classification to make it more precise and complete. Third, we can optimize our rules. We can generate specific contents on rules for each sentence and compare the cybersecurity document of each country to the UN cybersecurity requirements to check its completeness. Thank you for your listening. This is our whole presentation.